Here is something that should quietly stay with you long after this video ends. Every star you have ever seen, every galaxy ever photographed, every planet, every ocean, every person, every atom of everything that has ever been touched or measured or loved, all of it together is a small minority of the universe. Most of what exists is something else, something that has never once reflected light into a human eye, something that passes through your body, through the earth, through the core of the sun, without leaving a mark. And yet, without it, there would be no galaxies, no stars, no you. Tonight, we are going to follow a single question as far as it will go. What is holding the universe together? And why can no one see it?
It sounds like a question that should have been answered a century ago. We have mapped the cosmic microwave background, the oldest light in existence. We have photographed the shadow of a black hole. We have detected ripples in space-time itself from collisions a billion light years away. And still, when astronomers weigh the universe, when they add up everything that shines, everything that glows, everything that can in principle be seen, the numbers refuse to work. The visible universe is not enough to explain the visible universe. Something enormous is missing from the ledger. Not a small rounding error. Roughly 5 times more mass than everything we can see combined. The intuition says that if something is that massive, that dominant, that everywhere, it should be obvious. The physics says otherwise. And that gap between what should be obvious and what remains invisible is one of the deepest open mysteries in all of science. If you're new here, welcome. Get comfortable, dim the lights if you like, and stay with us, because tonight we're going to follow this question down, layer by layer, as far as it can take us. The beautiful lie of the night sky. Begin with something you have done your whole life. You step outside on a clear night, far from city lights, and you look up. Thousands of stars, maybe the faint silver river of the Milky Way arching overhead. It feels complete. It feels like you are looking at the universe, the whole inventory of what exists laid out above you in points of ancient light. This is the most natural assumption a mind can make, that seeing is a reliable guide to existing. For almost all of human history, astronomy was simply the study of light. Light was not just how we learned about the universe. Light was the universe, as far as anyone could tell. Every advance, the telescope, the photographic plate, the spectrograph, the space observatory, was a better way of catching light. And so, quietly, without ever stating it out loud, we built our entire picture of reality on a single assumption: that matter announces itself, that mass glows or burns, or at the very least blocks the glow of something behind it. Now hold that assumption in your mind, because we are about to watch it fail. Think of the night sky as a photograph of a city taken from an airplane at night. You see the streetlights, the office windows, the headlights tracing the freeways. It is tempting to believe you are seeing the city, but you are not. You are seeing the lights of the city. The buildings themselves, the concrete, the steel, the millions of sleeping people. The overwhelming majority of what is actually there is invisible in that photograph. The lights are just the glowing edge of something far larger and darker. For most of the 20th century, astronomers believed the universe was like city lights, It turned out to be the city. But this is still only the surface. To understand how we discovered the darkness, how we learned to weigh what we cannot see, we need to go back to a moment when the universe very politely refused to obey its own rules. The galaxies that should not exist. In 1933, a Swiss astronomer named Fritz Zwicky was studying a swarm of galaxies called the Coma Cluster. Over 1,000 galaxies bound together by gravity, orbiting their common center like bees around an invisible hive. Zwicky did something simple and devastating. He measured how fast the galaxies were moving. Then he added up all the light in the cluster to estimate its mass. And the two numbers did not match. Not by a little. The galaxies were moving so fast that the visible mass of the cluster should have been utterly incapable of holding them. By his arithmetic, the cluster needed hundreds of times more matter than anyone could see, or it should have flung itself apart long ago, a swarm with no hive, scattering into the void. Zwicky coined a phrase for the missing component, dunkle materia, dark matter. And then, for the better part of 40 years, almost no one took it seriously. The measurement seemed too strange, the conclusion too large. It is one of the recurring lessons of science. Sometimes the universe tells us the truth decades before we are ready to hear it. The moment we became ready arrived in the 1970s, and it arrived through the patient, meticulous work of an astronomer named Vera Rubin. Rubin was not chasing exotic physics. She was measuring something almost mundane: how fast stars orbit within spiral galaxies, from the bright, crowded center out to the thin, lonely edges.
Here is what intuition and Newton would predict. A galaxy's light is concentrated at its center, so its mass should be too. Stars near that center should orbit quickly, gripped by all that nearby gravity. Stars far out at the rim should drift slowly, the way Neptune crawls around the sun while Mercury races. Plot orbital speed against distance, and the line should rise, peak, and then fall away. Astronomers even had a name for the expected shape: a rotation curve. Rubin pointed her instruments at the Andromeda galaxy and began to measure. Near the center, the speeds rose, just as expected. Then, farther out, where the speeds should have begun their long, graceful decline, they didn't. The curve went flat. Stars at the ragged outer edge of the galaxy, where the starlight fades to almost nothing, were orbiting just as fast as stars deep in the luminous interior. She checked another galaxy. Flat. Another. Flat. Dozens of galaxies and the same impossible answer every time.
Pause on what this means, because this is the part that almost no one truly absorbs. Those outer stars are moving so fast that the visible galaxy cannot hold them. Every spiral galaxy you have ever seen a photograph of, every serene, majestic pinwheel of stars, is spinning fast enough to tear itself apart. By the gravity of its visible matter alone, it should be shedding stars into intergalactic space like water flowing from a spinning umbrella. And yet, the galaxies are still here, after more than 10 billion years, calmly holding their shape. Something is holding them together, something that does not shine.
The flat rotation curves allowed astronomers to do something extraordinary: to weigh the invisible. If the outer stars move that fast and remain bound, you can calculate exactly how much unseen mass must be present and where. The answer reshaped our picture of what a galaxy even is. The bright spiral, the part we photograph, the part we name, is only the glowing center of a vastly larger structure, an enormous, roughly spherical halo of invisible matter extending far beyond the last visible star. The galaxy you see is like the small bright wick at the center of a vast dark flame. The response of a careful mind at this point is exactly the right one. Maybe the missing mass is just ordinary matter that happens to be dark, cold gas, dust, dead stars, wandering planets, black holes. The universe is full of things that don't glow. Surely the missing mass is simply matter hiding in the dark. It is a perfectly reasonable idea, and it is wrong. The next layer is where the mystery stops being an accounting problem and becomes something far stranger.
Science, at its best, works as a detective story told in reverse, not by finding the culprit, but by eliminating every innocent suspect until only the impossible remains. Over the past half-century, astronomers have hunted down every form of ordinary matter that could be hiding in the dark, one by one. And one by one, each suspect has been cleared. Cold gas was the first. Gas is dark in visible light, but it is not silent. Hydrogen hums at radio frequencies. Warm gas glows in X-rays. When astronomers surveyed the sky at those wavelengths, they found enormous reservoirs of gas, genuinely vast, in clusters even outweighing the stars, and still nowhere near enough to explain the motion. The books still would not balance.
Then dust. But dust betrays itself by dimming and reddening the starlight passing through it, and it whispers in infrared. Measured, catalogued, and dismissed. A trace ingredient, thousands of times too scarce. Then came the more romantic suspects. Dark, compact objects. Burned-out stars. Rogue planets. Black holes drifting through the halo like silent ships. Astronomers gave them a name, machos, massive, compact halo objects, and devised a beautiful way to hunt them. Einstein's relativity says mass bends light. If a dark, heavy object drifted in front of a distant star, its gravity would act as a lens, briefly magnifying the star in a telltale flicker. So teams monitored millions of stars, night after night, for years, waiting for the flickers. The flickers came, a handful, far, far too few. The halo is not made of dead stars or wandering planets or hidden black holes. Whatever fills it does not merely refuse to shine, it refuses to be anything we have ever cataloged. And then physics closed the final door. And this is the detail that changes everything. It comes from the first few minutes after the Big Bang, when the entire universe was a furnace forging the first atomic nuclei. The physics of that furnace is exquisitely sensitive to one number: the total amount of ordinary matter, protons and neutrons, in existence. The amounts of hydrogen, helium, and lithium that emerged from those first minutes are a permanent receipt, printed at the beginning of time, recording exactly how much ordinary matter the universe contains. We have read that receipt. The measured abundances of the light elements, and independently, the pattern of ripples frozen into the cosmic microwave background, the ancient light we followed in our first episode, both give the same verdict. Ordinary matter, all of it, everything made of atoms, seen or unseen, accounts for roughly 1/6 of the matter in the universe.
The rest, about 5/6 of all matter, about a quarter of everything that exists, is not hidden atoms. It cannot be atoms. It is something that was present in that primordial furnace and did not participate. Something that does not emit light, does not absorb light, does not reflect light, and does not interact with light at all. Matter, but not as we know it. Mass without a face. The intuition wants to object here. It wants to say that anything real must be, in principle, touchable, that matter means substance, and substance means surface, and surface means something a hand could meet. But that intuition was trained on tables and stones, on one thin category of matter that happens to interact with the electromagnetic force, which is the only reason tables feel solid and stones reflect light in the first place. Remove that interaction, and you can have mass, gravity, motion, structure, everything that makes matter matter, with nothing to see and nothing to touch. The universe is not obligated to be built entirely out of the kind of material that built us. But if it cannot be seen and cannot be touched, how could we possibly know where it is? This is where the story turns, because it turns out the invisible casts a shadow after all, not in light, in gravity.
Einstein gave us the key a century ago. Mass curves space-time, and light must follow that curve, which means every massive object in the universe, visible or not, is a lens. Point a telescope at a distant cluster of galaxies, and the images of even more distant galaxies behind it arrive stretched, smeared, and arced, their light bent during its long journey by every gram of mass it passed. Read those distortions carefully enough, and you can do something that sounds like it should be impossible. You can make a map of the invisible. Astronomers have made those maps, and the invisible has a shape. Around every galaxy, the lensing reveals the vast dark halo the rotation curves predicted. Around every cluster, an enormous reservoir of unseen mass, dwarfing the glowing galaxies embedded in it. The visible universe hangs inside the invisible one like lanterns strung through a dark forest.
And then, in one place in the sky, the universe staged something very close to a decisive experiment and photographed it for us. It is called the Bullet Cluster, two colossal clusters of galaxies that slammed through each other hundreds of millions of years ago. In that collision, the components separated. The hot gas of the two clusters, which is most of their ordinary matter, crashed together, compressed and slowed, left glowing in X-rays near the collision point, like the crumpled wreckage of an impact. But the lensing maps show that the mass, the overwhelming bulk of each cluster's gravity, did not stop. It sailed clean through, ghost-like, unslowed, and kept going, separating from the wreckage entirely. In a single image, the universe shows us ordinary matter in one place and the dominant mass in another. The dark matter passed through the collision, through billions of suns worth of searing gas, as if nothing were there. Because for dark matter, effectively, nothing was. Now widen the view, all the way out. Because the deepest role of this invisible substance is not in any single galaxy or cluster. Map the positions of millions of galaxies across billions of light years, and a pattern emerges. Galaxies are not scattered randomly. They lie along immense filaments, gathered into knots and walls, wrapped around gigantic voids, forming a structure astronomers call the cosmic web, the largest pattern in nature, a web of light spanning the observable universe. That web is not made of galaxies, it is traced by them. The filaments are dark matter. The galaxies are simply where the darkness gathered thickly enough for ordinary matter to fall in, pool, and ignite into stars. Every galaxy is a lantern hung on an invisible thread.
And here is the part that becomes quietly personal. Run the universe backward to the beginning and ask what would have happened without dark matter. In the early universe, ordinary matter had a problem. It was locked in a blaze of light, and that light's pressure kept smoothing it out, erasing every attempt to clump. Ordinary matter alone could not begin building anything until far too late. But dark matter, blind to light, felt no such pressure. While the visible universe was still a glowing fog, forbidden from gathering, the dark matter was already silently pooling, already deepening its wells, already laying the foundations. When the fog finally cleared, when the first light was released on its long journey, the light of our first episode, ordinary matter found the scaffolding already built and
fell in.
Without the darkness, there would not have been enough time. No galaxies, no stars, no heavy elements forged in stellar furnaces, no planets, no chemistry, no life. Every atom in your body was gathered, held, and assembled inside gravitational wells dug by a substance that has never once touched you. The thing no one can see is the reason there is anyone to look. So we know its gravity intimately. We have mapped it across the sky. We know it was there before the first star. Surely then, we are close to knowing what it is. This is where the story takes its strangest turn, because the closer we look, the quieter it becomes. If dark matter is a particle, and for decades that has been the leading idea, then it is everywhere. It does not orbit neatly like stars, it swarms. The halo of our own galaxy passes through the solar system, through the Earth, through this room. Millions of dark matter particles are likely streaming through your hand in the time it takes to hear this sentence. They pass through the planet as easily as light passes through clear glass, because to them, the Earth is barely there. But perhaps, physicists reasoned, not perfectly. Perhaps, very rarely, a dark matter particle might graze an atomic nucleus directly. A collision not of surfaces, which neither has, but of something deeper. If so, the nucleus would recoil, ever so slightly, like a bell struck softly in a silent room. All you need is the quietest room ever built. So, we built them. In mines and mountain tunnels, kilometers beneath the surface, beneath enough rock to silence the constant rain of cosmic rays, physicists have constructed the most sensitive detectors in history. Vats of liquid xenon, ultra pure, colder than the void, watched from every side by instruments capable of registering a single flash of a few photons. Everything about these experiments is an exercise in subtraction. Subtract the cosmic rays. Subtract the natural radioactivity of the rock, of the steel, of the detector itself. Subtract everything until what remains is a silence so complete that a single whisper from the dark would be unmistakable. For decades, generation after generation of these detectors, each 10 times more sensitive than the last, have kept their vigil in the deep places of the Earth, waiting for the bell to ring. The bell has not rung.
Let that sit for a moment, because its meaning is double-edged. These experiments have not failed. They have succeeded magnificently at ruling things out. The most favored candidate, a heavy, weakly interacting particle that theorists had elegant reasons to expect, the so-called WIMP, has been pushed into an ever-shrinking corner. Whatever dark matter is, it interacts with ordinary matter even more feebly than our most pessimistic early estimates. Each silence is a discovery, but each silence also deepens the question. We have now searched with exquisite precision exactly where our best theories pointed, and found the universe holding its breath. So the theorists have widened the search, and this is where the frontier lives today. And to be clear, from here forward we are in the realm of open research, of hypothesis rather than settled fact. Perhaps dark matter is not heavy at all, but almost unimaginably light, a particle called the axion, so insubstantial that it would behave less like a swarm of particles and more like a vast, slow field humming through the galaxy, a note held for billions of years. Experiments are listening for that hum right now. Perhaps dark matter is not one thing, but many, an entire hidden sector of particles with its own forces, its own interactions, its own unseen physics, a shadow chemistry unfolding alongside ours, connected to us by gravity alone. Perhaps some of it is ancient black holes, born not from stars but from the first violent moments of the Big Bang itself, a possibility mostly, but not entirely, closed. Each of these is a serious scientific idea. None of them is yet an answer. And there is one more possibility, the heretical one, the one that asks whether we have been hunting a ghost of our own making.
What if the darkness is not there at all? Every claim we have made tonight rests on one silent assumption, that we understand gravity. Every measurement of missing mass is really a measurement of motion, translated into mass using the laws of Newton and Einstein. But what if the laws themselves are the thing that fails? What if, at the faint accelerations found in the outskirts of galaxies, accelerations 100 billion times weaker than what holds you to your chair, gravity simply behaves differently than we assume? Then there would be no missing matter at all. The universe would not be hiding anything. We would merely be reading it with the wrong grammar. This idea has a name: modified Newtonian dynamics. And it deserves to be taken seriously, because in its home territory, it performs almost eerily well. With a single adjustment, it predicts the flat rotation curves of galaxies, and it captures a strange, tight relationship between a galaxy's visible matter and its motion that the dark matter picture explains less naturally. If galaxies were the whole universe, the case might be genuinely undecided. But galaxies are not the whole universe, and this is where the modified gravity idea begins to struggle. It strains to explain the clusters where even modified gravity still needs unseen mass. It has no easy answer for the bullet cluster, where the gravity is measurably in a different place than the ordinary matter, a separation that a mere change in the law of gravity should not produce. And it falls quietest before the oldest evidence of all, the pattern of ripples in the cosmic microwave background, which records the universe balancing two components, one that felt the pressure of light and one that did not, with a precision that the dark matter picture matches ripple for ripple. So the scientific mainstream holds, for good reasons, that the darkness is real, a substance, not an illusion. But intellectual honesty requires saying the rest. The mainstream picture has its own unresolved tensions at small scales. The particle has not been found, and the debate is not fully closed. This is what an open frontier actually looks like. Not ignorance, but a hard-won map with a region at its center that still says unknown. And notice what has happened to our question. We began by asking why no one can see what holds the universe together. We now know the answer to that part, and it is stranger than blindness. It cannot be seen because it does not speak the language of light at all. Sight was never going to work. The real question has quietly become something much larger. Why is the universe mostly made of something so profoundly unlike everything we are? Step outside again, one more time, under that same clear night sky. Nothing about it has changed. Everything about it has changed. The stars are still there, ancient and patient. But now you know they are the minority, the visible foam on the crest of a dark ocean. Around every constellation you can name, an invisible halo, vaster than the visible galaxy, holding it silently in place. Between the galaxies, immense filaments of unseen mass, the true architecture of the cosmos, on which the glowing web of galaxies hangs like dew on a spider's silk at dawn. Through the sky, through the earth, through you right now, a soundless wind of something that has been streaming through this spot since before the sun existed and will continue long after it. There is a humility in this that previous generations never had to face. Copernicus moved us from the center of the universe. Darwin folded us into the tree of life. Hubble scattered our galaxy among billions. And now, quietly, over the past 50 years, we have learned something further. The kind of matter we are made of, the kind that shines and binds into atoms and thinks, is not the main ingredient of reality. We are the exception. We are the rare, luminous residue of a universe whose substance is mostly something else. And yet, and this is the part worth carrying with you, that is not a diminishment. Consider what the darkness has done. It gathered when nothing else could. It built the wells into which the first atoms fell. It held the young galaxies together while they were still fragile, spinning too fast to survive alone. It is, in the most literal sense, the reason structure exists, the silent partner in the making of every star, every world, and every mind that has ever looked up and wondered. We do not know what it is, but we know what we owe it. Perhaps that is the truest answer to the question we started with. Why can no one see what holds the universe together? Because the universe is under no obligation to be made of things like us. Because light, which we mistook for the whole of reality, was only ever the visible edge of it. Because the deepest structures are often the quietest ones. The foundations are always underground. Somewhere beneath a mountain tonight, in a chamber of perfect silence, a detector is waiting for a whisper. Somewhere above you, an invisible halo turns with the galaxy, keeping the stars from scattering, as it has for 10 billion years. Between those two silences, the one we built and the one we were born inside, lies one of the great unanswered questions a human being can ask. You have spent your whole life inside the answer. It is holding you and everything together, right now in the dark, without ever once being seen. And maybe that is the most remarkable thing the universe has told us yet, that the greater part of everything is still waiting to be discovered, and that it has been here, beside us, all along.